All right, I decided to do a quick video on the homework quiz from yesterday, just because I had a lot of the same questions come up, and I'm afraid some of you are afraid to ask me questions via Remind. So for those of you that might not have sent me a Remind message, I'm just going to go through this whole homework quiz real quick. So this problem was about this game where you just reach your hand into a jar and you grab as many coins as you can. So there were dimes and there were quarters. I underlined the key information about dimes in blue and the information about quarters in red. I'll try to keep the colors going throughout. So in part A, I think most of you got this. They wanted the amount of money from each dime grab, and they wanted us to call that D. So D is going to be 0.1. 0.1 because each dime is worth 10 cents times, I think I called it in my answer key, just a lowercase d for what's underlined in blue. So 0.1 times D is this new variable. That's a linear transformation. So if you remember from the notes, that means the new mean multiplying affects the old mean. So I just multiply the old mean that I underlined in the original problem. So 0.1 times 68. Sorry, I'm writing with my fingers. And that gives you $6.80 for the new mean for the dime grab. So it'll be a mean amount of money if you reach your hand in this jar and pick out some dimes. Part A didn't ask for the quarters, but you're going to need it in part B. So just here in the side for quarters, it works the same. So if I call it Q, each quarter is worth 25 cents. So 0.25 times however many quarters you grab. And the mean of Q works the same way. It's just 0.25 times the mean number of quarters you grab. So 0.25 times 42. And I think that was 17. No, let me see. That amount was 1050. And I'm a little ahead of myself. I forgot to do standard deviation, but multiplying also affects the standard deviation. Let's go back to my dimes real quick. So the standard deviation of the dimes, the amount of money grabbed, is also going to be 0.1 times the old standard deviation, which was 9.5. So that gives me a new standard deviation of 0.95. And then the same thing for quarters. I'll just give you that amount. It's going to be 0.25 times the standard deviation of 5.8. And that's $1.45. So the standard deviation for the quarter draw is 145. And again, that's not part of this problem, but we're going to need it in the next part. Now in part B, they want a new random variable, and they're going to call it T. And T is the total amount of money in dollars that someone grabs from both jars. So they reach in with their left hand into the dime jar and their right hand into the quarter jar. Well, how much money are they going to get out? So that variable T is going to be D plus Q. So the random variable D from part A and the random variable Q from part A that really wasn't part of part A, but we needed to do it for this part. This is combining random variables. So when you combine random variables to get your new mean, you just add your old means. So I'm going to stick with green here, but the new mean of T is going to be the mean of the dimes, which was 680. Plus the mean of the quarters, which was 1050. And that gives you a mean of 1730. That's a 7. I'm writing with my fingers. Standard deviation, regardless if this was add or subtract, this is obviously addition, but even if it was a subtraction, to find the new standard deviation, you add the variances. So I go up here to my standard deviation 0.95 and I square it. That's how I get the variance. And I add that to the variance of the quarters. So 145 squared. Again, that's what we found here in part A that we didn't need, but we need it here. And if you type that into your fancy Inspire, if you do it, you should get 1.734. So there's my mean and my standard deviation of this random variable t. And then C, I kind of go back to linear transformations. Let me pick a color I haven't used. So the casino operator plans to charge you $20 to grab in the jars. So G is how much the contestant gains. So the contestant, they're going to gain the total from part B. That's what they grab, but remember they had to subtract 20. So this is a linear transformation. 20 is a constant. It's not another variable. So I'm not subtracting a separate variable. I'm just subtracting a constant. So that means the new mean of G is the mean of T. So this 1730 minus $20 that they had to pay to play. So the mean gain in this game when you grab in the jars end up being negative $2.70. So not a game I want to play. And then the new standard deviation, if you remember from the notes on linear transformations, adding or subtracting a constant doesn't affect the standard deviation. So the same standard deviation in part B is going to be the standard deviation in part C. And that's it for number 1. I think number 2 we should be pretty set on because it's similar to the problems from the homework. At number 52 I did a video on, and it's similar to the speed dating problem. So I'm just going to leave this one blank. Most of my questions yesterday came from question 1. So there's your solution to 1 with my explanation. Again, feel free anytime to send me a remind message with questions. I'm pretty quick to answer.